Sound energy is emitted uniformly in all directions at a constant rate by a point source, and a person 8 meters from the source listens. If the intensity of the source is half and the sound is seen to be as loud as before, at what distance from the source should the person now be? Okay, this question is trying to say that if there is a source here at the center here, let's say the intensity initially is I, so this is intensity of the source, let's say. Okay, intensity of the source is the IS. Now, at 8 meters away, you will hear certain loudness. I call it intensity I. Okay, after that, the question says that the intensity of the source reduces to half of its original value, at which position that this person must stand so that he can listen back the same loudness as just now. So, obviously, the loudness initially is 8 meters. Now you reduce the intensity by half. You must stand nearer, right? You must stand nearer, let's say X meter, to hear back the same loudness of the same intensity I here. Okay, they are the same. Okay, use back same color, they are the same loudness. This I and this I are the same. Now, how do we solve this problem? First of all, we need to be very fast to identify that when this intensity is IS, we can say the power is PS. When the IS over 2, the power of the source become 2 as well. Because why? Because intensity is power over the area. Intensity of the source, power of the source, area of the source. Since the area of the source is at this point doesn't change, that means the intensity of the source is proportional to power of the source. When the intensity is reduced to half, when the intensity reduced to half, the power of the source also decreased to half. Alright, so let's look at the first case when the intensity is still IS and the intensity at the distance 8 meters is I. So how do we solve this problem? Okay, now we cannot use intensity IS and we got to use PS. We know that intensity is power over the area. So intensity at this position here, I say this as I. Okay, this intensity at the certain 8 meters away, I can say this is the power of the source divided by the total area here, total area, because the power of the source is equally distributed in this whole big area, and this whole big area is 4 pi r square. Okay, this is the intensity at this position. Alright, now at the new place here X, the second case here, when the intensity of the source is reduced to half, that means the power of the source also decreased to half. But we want to hear back the same intensity I. Okay, we want to hear back the same intensity I. So the next case is the power of the source become divided by 2, right? The power of the source, the next case is power PS over 2. And the distance now is X, so become the area become 4 pi X square. 4 pi X square. Okay. Now, very simple. Equation 1 equals to equation 2. You just equate them. So PS over 4 pi X square equals to PS over 2 divided by 4 pi X square. You do some simplification. X you will get is 4 root 2 meter. The answer is D.